In this video, we will see dry run of the code. Now let's quickly do the dry run of this problem. So here you can see I have this recursion stack. Okay, I will tell you how this will work. Okay, we will create a recursion tree as well. And let's suppose my S string is A, B, C with the indexes of 0, 1, 2. Okay, so where I am calling this function, I have created one array. So let's suppose I have an array. Okay, I have one string that is an empty. Okay, that is an empty string. Okay, then I am calling this function. So I am calling this function sub. So let me call sub function as s because there is not relevant space. So I am calling s with an empty string with the s abc, and with I am calling, let's suppose instead of s, let me call this as g, right, generating subsequences, right? So it will be different from the s. Okay, so it will be g and the index is 0. So you can see I am at here, my index is at here. So I will execute this function now. Is index is equals to s dot length? No. What is the s dot length? S dot length is equals to 3. Okay, and index is 0, so no, it is not equal. Okay, so what I will do, or okay, yeah, remember this thing, right? I hope this is clear to you. So index is not equals to length. I will call this function sub, taking the element and moving forward. So I will call this function g. I'm taking it, so I will have a, right, s, and index will be 1. So I'm calling g. Okay, you can call it like first this function, so g with an empty string s comma 0, then I am calling g with a and s and comma with 1. Okay, and let me increase its size so that we will get enough space. Okay, now after this, right, I will come here, I will execute this function a, right? Now my string that was str was simply string will have a, right? So what I will do, I will complete this function. So I will complete this function. Is my index is equals to s dot length? No, index is now at 1. Index is now at 1, which is not equals to length. So I will again call one function, again one call. So again call this function and I will take the next character str plus s of index. What is the index? Index is 1, right? So I will take a with b, right, and s with 1. So next function call will be ab with s and 2, right? It will become index plus 1, remember, right? 0 to 1, it will become 2, index plus 1. Now I'll execute this one. So I will execute this one, right? Is my index is equals to s dot length? No, index is 1 only, right? Index is 1, 2 only, right? Index is moving to 2, index is 2 only, that is not equals to s dot length. So again one function call, again I will do one function call, and I will take the next character that will be abc s. Now it will be 3. So now you can see in your string is not a, ab is also done, and abc, now you have abc. Okay, so now let's execute this function. This will come under the recursion stack abcs3. Now once you have reached this one, now you will check what is your index. Okay, index will move forward because index is pointing to 3. Is your index is equals to s dot length? Yes, s dot length is 3, index is also 3. So what I will do, I will say array dot push string. What is the string? That is abc. So I will push abc, right? Once I have pushed it, I will say return. When I am returning, I will return back to it. I will return back to this function. So when I will return, I will be at this function. Okay, this is done, right? So I will come to this function now. This task is done. Okay, right? So when I am returning, I will come back. Basically, this function is over. I will call this function now. What is this function? Right? Again, one function call. That is, first of all, this task is done. Basically, this is done. This is returned. Okay, then I will call this function str. So I will call this with the same ab, right, and index plus 1. Okay, I am not adding the c here. So this will be one function call. Okay, so this one will be one function call ABC, not ABC, AB only, and S with 3, right? Again, now I will first execute this one. How I will execute? I will check what is the index. Index is equals to 3. Index is equals to 3. I will say arrow dot push str. What is str? AB. I will push AB, right? And once I push it, I will return. So I will return from this index, this function call. So this function call work is done, right? So I will remove from recursion stack also. Okay, now you can see my this function completed both the work, right? Basically it work was to execute this function and this function, both the function work is done. Okay, and now there is nothing left. I will return from here as well, right? So I will return from here. So mera abs2 work is also done. Okay, that is also done, right? Now what I will do, let me remove this one. You have executed this one, you will come to this one. Okay, so I will call this one G with the same character, not adding the B. I will call A with S with the 2. Okay, so I will call G with A with S and an index of 2. Okay, my index is at 2 here. Now when I will execute this one, I will check is my index is equals to s dot length. No, s dot length is 3. Again one function call str of plus index. So what I will do, I will again do one function call. It will be G A and S of index. What is S of index? That is C. So I will say AC S and it will be 3. So it will be G AC S and 3. I will execute this one first. So if I am executing, I will check is my index is equals to s dot length. Yes, it is equals to 3. Yes, it is, right? So you will push str. What is str? That is AC. So you will push AC and you will return. So you will return from here as well. Once you will return, this will also remove from the recursion stack, right? This will remove from the recursion stack, right? Now you have a second function call, right? Once you are returned from it, now you have a second function call when you are not taking C. So it will be G with A with S and with 3, right? So AS2 is done, right? Now I will call GA with S comma 3. Now let's first execute this function call. Okay, is my index is equals to s dot length? Yes, it is, right? So push the str. So I will push A. I will push A, right? This A, and I will return. So I will return from here as well, right? So I will return from here. Now this function call checked with two function call. Basically the work is to do two function call, that is done. So can I say this will also return? Yes. So AS3 is done. After AS3, AS2 is also done. This all is removed from the recursion stack. Now can I say my AS1 is also done? Basically the work was to call this one AB and then without A, by picking call, not paying call. So yes, this work is also done. So it will also return, right? It will also return to here, right? Now what I will do here, here, okay, I have done only one function call. Now there will be a next function call when I am not taking. This is a pick case when I am not taking it, right? So I will remove this from the recursion stack because the work is done. If I am not taking A, that will be an empty string with S with an index plus 1. Okay, and again the same, basically the same recursion tree will happen here as well, right? I'm just putting here a bit side so that I can write it here, but you can understand, right? The same function tree with the V. Again one function call if you are taking V, right? I will execute this function call. I will check is my index is equals to s dot length. No, index is equals to 1. Again two function calls. So I will call it again when I will take that character str plus s of index. What will be my index, right? Index is 1. So I will take my index is 1 right? So I will simply take b, right? So I will take b s of 2. Index will become index plus 1. So I will first execute this one. Okay, now here space is not left, but I hope you got the point, basically how the function is calling one by one and how it is returning. Okay, so you can see, right, I'm calling these two function calls. So these are two function calls and these are returning as well. Okay, and you can see now you are clear with it. Your recursion tree goes this to maximum, right? One function call, then after one function call, this one function call, then this one, then this one. So this is the highest length of the recursion stack, highest from the root node to the leaf recursion tree. Okay, so that's why the space complexity of the recursion stack auxiliary space was big O of n. That is, n is the number of function calls, what is the number of string. Okay, and basically this is how it works. Okay, again, pick not pick call, pick not pick call, each with the pick and not pick call, and this is basically this is known as your recursion tree. So when you will create recursion tree and recursion stack, everything will become cleared. Okay, so that's all about this problem. This was the one basic problem, but I'm very sure that from this problem all your backtracking concepts will be very brushed up. You are almost ready to solving 10 problems. Okay, in way you can simply solve 10 problems, okay, on the same concepts of generating subsequences. We'll solve more problems on backtracking. Okay, so see you in the next problem where we are using again backtracking the recursion techniques to solve a particular problem. Okay, see you in the next video then.